Hello, everyone. We, Code Green Trio, will be presenting a thorough data analysis of the impacts of climate change on biodiversity and the populations of wildlife species around the world. Let's dive into our presentation prepared by us climate analysts, Hafsa, Samavia, and Alina.
Data analysis project focuses on the dire issue. For many centuries, we have witnessed a massive decline in wildlife populations across the globe. The global rise in temperatures can be linked to this issue, which not only affects the number of individual organisms, but also disrupts major ecosystems, forcefully imposes animal migrations, and poses challenges on their survival. We will explore this issue in detail by using data on global temperature anomalies and wildlife populations.
There are many factors contributing to this unfortunate situation. Global warming is one of the most drastic, caused by a number of other reasons, including greenhouse gas emissions and deforestation. These not only speed up global warming, but also have a part in the destruction of the habitats of various wildlife, cause extreme weather events or irregular climates that demolish ecosystems, and much more. We incorporated data science in our project to display the various datasets and relationships between the two factors. We used the Python editor, Google Colab, to convert the datasets that we collected into data frames that can be displayed by the computer. This data chart showcases the Living Planet Index, an index used to observe the change in populations of a wide range of species around the world. As you can see, there has been a heavy decline of wildlife populations over the past 50 years. This is the data chart that we have created in Google Colab, the Python editor, that showcases the visualization of the Living Planet Index. The steep drop of wildlife population since the 1970s in the world is clearly shown on this graph. After displaying the data chart for global temperature anomalies, the relationship between the two elements will be seen.
We showcase the data for shifting temperatures also using Python programming in Google Colab. We were able to compile the dataset into a filtered chart to display data about global yearly temperature anomalies. These can help us figure out how much the temperature shifted from its usual amount annually and discover trends and patterns relating to the findings.
Now, let's see how we created this important visualization. First, our program collects the data, wildlife population numbers from conservation groups and temperature records from climate scientists. It focuses specifically on global averages. Then, it combines these datasets by matching their years and calculates how closely they are related. A negative correlation meaning when one goes up, the other goes down. Now, let's talk about two critical sites of our planet's health: biodiversity and global temperature. Biodiversity is all the different life forms on Earth, including animals, plants, and entire ecosystem. We measure it using the Living Planet Index, or LPI. When the LPI drops, it means species are disappearing. At the same time, our planet is getting warmer. The temperature anomaly shows how much hotter Earth is compared to historical averages. So, as the temperature rises, biodiversity falls. Warmer weather disrupts habitats, melts ice, and causes extreme weather, all making it harder for species to survive. Over here in the graph, blue line shows biodiversity, red line shows temperature. The message over here is very clear. As the red line climbs, the blue line falls. Faster warming means faster species loss. This is why protecting ecosystems and fighting climate change matters for every species, including ours. This correlation data chart of the previous two datasets clearly show how the rise in global average temperatures corresponds with the decline in wildlife populations. The inevitable trend is undeniable. As temperatures rise, wildlife populations continue to fall.
This serves as evidence that climate change is having a severe, harsh impact on biodiversity. However, this trend is not exactly inevitable. It is not unavoidable. There are many ways in which we can mitigate the impacts of climate change on biodiversity on Earth, including ways in which we as individuals can contribute.
Feature is utilized to better annotate our graph and make it easier to note down and collect specific readings. When the cursor is hovered over any part of the line on the graph, it will instantly show a short description of the data being shown at that exact location on the line. It is much more efficient and shows the data clearly. Regression line, similar to a line of best fit, shows how the elements on the graph are related. It is drawn through the graph according to where most of the points on the graph are located and displays the overall trend across all the points. On this graph, the regression line shows that as the value of the temperature increases, the value of the living planet index decreases. The animation chart brings life to the graph. It makes the graph more interesting as moving elements are added to it. This also allows the data to be more easy to follow and engaging to viewers. Connections can also be clearly seen, as viewers can watch lines go across the graph according to data live.
Climate change is hurting nature and making the planet hotter, but there are things we can do to help. First, we can protect and restore places like forests and wetlands. These areas are home to many animals and plants, and they also clean the air by taking in carbon dioxide. Next, we can use clean energy like solar and wind power instead of burning oil or gas. This helps to stop gases that make Earth warm. And finally, by taking care of our land and using it wisely, we can protect nature and keep the planet cool.